This is true for all the n larger than 2. Before we prove it, we should study what does it mean. N larger than 2, right? So this guy has to be 2, 3, 4, and so on. So write down a few case, base case, there is 2, then you have, and then let's say n is 3, you have. So you want to put it by induction. So induction, you have 2 steps. One, you have the base case. That means you want to prove this is true, okay? Just to let you know, the proof symbol looks like this. And then the second step is you have a hypothesis case that is for n equal to k, okay? You use this to prove the next case, that is k plus 1 is true, okay? So basically it's these 2 steps. So you want to prove this one. You don't need to care about this. This is just for your understanding. So let's prove the first one. Prove this, okay? When you see square root, you don't like square root. You want to remove the square root, so you do square. If I do square, so you write this, okay? So what's the idea? Idea is a larger than b if and only if, here's the important thing, a larger than b larger or equal to 0, which is the case, right? If and only if a square larger than b square, okay? That means from here you can go down, from the thing below you can go up, and of course this larger than 0, this also larger than 0, but this is hidden, okay? But it's true. So we have this. Why do this? This kills this, okay? And we don't like to see this. So what we have? We have kill this 1. So we now have 2 plus half larger than 1. Okay, kill this with half. You don't want to see square root. Then you have 4, 2. Okay, true, done. These are all if and only if. So here is true, here is true, here is true, here is true, here is true. Now we want to prove the bullet point rule. This is true for k, so I just copy everything. 1 plus square root 1 plus 1 plus square root 2 plus dot 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 plus up to square root k larger than. Draw a blue box here. Now I want to show this is true for k plus 1. So I want to show this new stuff. This is what you want to show. So you have this bunch of thing, okay? You have this bunch of thing plus red thing, right? So we have the red thing. This sentence I am copying here by h, which is the blue box. This whole thing, which is exactly this whole thing, larger than this, okay? And the red thing, I just copy. So basically, this is what I have. This is by h. What's the goal? This guy larger than this, right? You see, there is what? Square root. We don't like square root. We do this. What? A larger than b. If this larger than 0, you take square. Why do this? Square kills square root. Almost forgot. Induction case is true because k is larger than the base case. So k is any number, can be 3, 4, 5, 6. Look, that I didn't write the equal sign because equal sign is the base case. So that means k is larger than 2. Just make sure you understand what I'm saying. Because of the k larger than 2, then this is larger than 3. And of course it's larger than 0. How do you see this? You may think that, wow, this is larger than 0. It's so easy. You can prove it. Right? Then this is the same as this way. So this one, I can do the square. Here's the tricky part. So you can say, I want to do the square like this. You can do that. But I can feel that this will make everything very complicated. So I don't want to do that. So I will first multiply everything by this guy. If I multiply everything by this guy, so that means I will have plus 1, right? I want to prove this. I want to prove this. Right? So basically, your goal is to prove this is true. So basically, what you want to show is that this guy is bigger than this. They have 1. I can kill the 1. So basically, the same. I want to prove this thing is larger than k, which this is plus 1 of course is larger than yourself. Done. Now you see all this. How do you proceed? You go back. So you said k times k plus 1 is larger than k squared. Then this is if and only if you have the thing in square root, okay, which is k, and then you plus 1, okay. So you have this, you have this. What I show you is here, right? I can multiply this because this is non-zero, so I can take it back, so I can get this done. What happens if you proceed with this way? Oh my gosh, it may take 10 pages. No. Sometimes you want to prove something. There are multiple ways you can do that. Some way is longer than other way. And how do you know which way is better? Experience. That's why MadBook 100 pages. Good.